Howdy, folks. Today we are going to discuss Newton's third and final law. This is a law that deals with something called momentum. And momentum is basically the way that mass and velocity are related. So, if you look here, you'll see kind of a familiar desk toy, maybe. It's called a Newton's cradle. And what happens is when the ball on the left hits the other balls, it causes the single ball on the right to go and move, and then it kind of repeats that pattern. And what you will see is that when that ball on the right hits, it transfers its momentum. And because the ball on the right has the same mass as the ball on the left, it actually then moves at the same velocity the ball on the left was moving. If you were to take two balls and do the same thing and hit the two balls, you would have two balls move at the same velocity as the other two balls on the other side because they have the same mass. Same with three and same with four. So let's talk about how all of this works. Our learning targets for today are I can explain and identify action and reaction forces according to Newton's third law of motion, and I can calculate and determine the correct units for the momentum of an object and understand the law of conservation of momentum. All right, notes set up for today. Your topic is Newton's third law, and your essential question is how are actions and reactions related? All righty, folks, let's go ahead and start off by pausing this video and heading over to your Nearpod and checking out this video from everyone's favorite scientist, Bill Nye the Science Guy. All right, so that's a nice little introduction to momentum and Newton's third law. So let's go ahead and start off with what is Newton's third law. And Newton's third law is actually a pretty common saying. In scientific terms, every force exerts an equal and opposite force. But also, that can kind of be simplified or changed to every action has an equal opposite reaction. So, here's what this means forces act in pairs. You have the action and the reaction. So, let's look at this little cartoon here. You have a boy standing on a skateboard. So, when the boy jumps, okay, he is pushing the skateboard because when he jumps, he is pushing back on the skateboard. And as a result, the skateboard is pushing the boy. And so, as a result, when this boy jumps, he pushes the skateboard and the skateboard moves backwards and the boy moves forwards. And those are examples of action and reaction forces. So, that's a pretty straightforward one. Let's look at another a rocket. So, the rocket thrusters push the exhaust gas downwards, and those gases then push the rocket upwards. And so the action is the thrusters pushing that gas downwards, and then the reaction is going to be that the gas pushes the rocket upwards. So action, reaction. So as you're taking notes, try to name at least three action reaction forces that occur in your notes. What question does the previous slide answer? All right, so the question you have is that why don't the forces balance out? And so here's the deal. Forces always act in pairs. And the reality is that the forces act on two different objects. And the net force is not going to equal zero because the objects are different sizes. And so, if you have a man stepping off of a boat, the man and the boat have different sizes, different masses. And so as a result, the action and reaction is going to be different. If the man has a lot more mass than the boat, his velocity when he exits the boat is going to be relatively slow. But the boat with a much lower mass is going to move much faster because their momentum, what's called momentum, which we'll talk about in a moment, has to balance out. The man has more mass, and so he moves slower. The boat has less mass, and so it moves faster. So, in your notes, you will see there is we have a worksheet on Newton's third law, but action reaction pairs. So, this is pretty straightforward. If you have a bat hitting a ball, the that is the action. The reaction is going to be that the ball hits the bat. So if you've ever played baseball and you swing a bat and you hit a ball, you're going to know that two things happen. Number one, the ball is hit by the bat, and so the ball travels away. But the bat that you are holding, you will feel the ball push back on the bat, and the bat kind of vibrates and maybe stings your hands a little bit. And so that is your action reaction, is that the bat hits the ball and the ball hits the bat in the equal and opposite directions. If you take your hand and you boop your nose, you will notice that your hand touches your nose. So for me right now, my finger is pushing on my nose, but not only does my nose get pushed, my finger can feel my nose touching my hand, touching my finger. So you touch the nose pushes back. If you pull on a flower, so you have a hand pulling on a flower, the result is that the flower is also going to pull on the hand. So it's not like you just easily move, but you actually feel resistance from the flower. Action reaction pairs. So on here, on page 21, go ahead and make sure that for each object the bat hits the ball, draw an arrow pointing in the opposite and equal direction for the other object. So the ball hits the bat, or the bat hits the ball, causing the ball to go this way, but the bat is going to have a reaction of moving this way. Finger boops the nose pushes back on the finger, hand pulls on the flower is still going to pull back on the hand. What questions do the previous slide answer? All right, so what we're talking about here is momentum. And the question that we're going to try to answer here is what is needed to have a large momentum? So momentum is a property of a moving object that depends on the object's mass and its velocity. The more momentum an object has, the harder it is to stop the object or change its direction. So if you have more mass or greater velocity, you are going, or more mass, or sorry, more mass or greater velocity are needed to have a larger momentum. So if you have more mass, you have a larger momentum. If you have a larger velocity, you have more momentum. So let's think about it like this. Which has more momentum? A truck with a mass of 9,000 kilograms moving at 50 meters per second, or a moped or scooter with a mass of 180 kilograms moving at 10 meters per second? Well, the truck is going to be a lot harder to stop than a little scooter. And so this truck has a lot more momentum because it has a larger mass and it is moving faster. Therefore, it is going to be harder to stop the truck or change its direction than it is to change the scooter. So momentum relates both to the mass of the object and the speed, or the velocity. If you increase either of those or both, that is going to increase the momentum. So momentum is found by multiplying mass and velocity. So mass is measured in kilograms and velocity is measured in meters per second. We remember that from earlier in this unit. So when you multiply those together, you're going to get a unit for momentum, kilogram meters per second. Now, unlike when we were measuring force, there is not a simplified version of this unit. So you need to make sure that when you're writing the unit for momentum, you include kilogram meters per second. So unfortunately, I do wish that there was some simplified way of saying that, but there isn't. So that's what we got. All right, let's go ahead and take a peek at problem number 1 on page 21 of your packet. And the problem is, what is the momentum of a person rolling down the hallway on a scooter? So in order to find momentum, we need two pieces of information. We need mass and we need velocity. So if a person is on a scooter, we need to consider the mass of both the person and the scooter. So we have a 50 kilogram person and a 5 kilogram scooter. So we add their masses together and we get a total mass of 55 kilograms for the object that is moving down the hall. The average speed of the person and the scooter together is our velocity, and we do distance over time. So we know that the scooter has traveled 5 meters, and let's just say that it did that in 2.5 seconds. And so this person and scooter are moving at 2 meters per second. What is the momentum of the person and the scooter together? Well, momentum equals mass times velocity, which is P equals M times V. We use P as the variable for momentum. Momentum equals 55 grams, our mass, times 2 meters per second, our velocity. 55 times 2 is 110, and our unit is kilograms times meters per second. So there you go. That is solving for momentum. Very similar to a lot of the equations that we have done before, just, different numbers. What question does the previous slide answer? All right. So the next thing then is the law of the conservation of momentum. So we are not going to get too far into the details of this, but here's what you need to know about this. In a closed system, the total momentum of the system is not changed. So basically, if you do the math and you get a certain number for momentum, if an object collides with another object, that amount of momentum is going to be the same. It's just going to be transferred. And so this is where every action has an equal opposite reaction because the momentum is conserved between the two objects. So look here at a Newton's cradle, and you see when one ball hits, the other ball moves at the same velocity as the first ball, just in a different or kind of in the same direction and goes around. So what we're seeing here is that the balls have the same mass, and so when it hits, this ball is transferring all of its momentum to this ball, and so it then begins to move at the same velocity. If you use two balls over here, two balls would move over here because they have the same mass as those other two balls, and therefore they maintain momentum. So that is the law of the conservation of momentum. What question does the previous slide answer? All right, so let's do a couple of quick practice problems here so that you can make sure you understand the calculating momentum. So this is on page 19 of your packet, number 2. A marble is rolling at a velocity of 15 meters per second with a momentum of 60 kilogram meters per second. What is its mass? Go ahead and solve this problem and then write your answer here, and then we'll go over how to do it. All right, so the velocity of this marble is 15 meters per second. The momentum of this marble is 60 kilogram meters per second. And if we were to solve for the mass, we would do momentum divided by velocity. So if you are going to do that, you have 60 kilogram meters per second right here. You have 15 meters per second as your velocity, so you divide by that. 60 divided by 15 is 4. And when you divide kilogram meters per second by meters per second cancels out, and you're left with kilogram as your unit. And that makes sense because we're finding mass. So the mass of the marble is 4 kilograms. In reality, that's more of a bowling ball than a marble, but hey, whatever. All right, next problem. A fish jumps and hits the water with a momentum of 4,500 kilogram meters per second. If the fish has a mass of 310 kilograms, what is the velocity of the fish? So go ahead and try to solve this problem, and then we'll go over it together. Enter your answer here, please. All right. The momentum of the fish is 4,500 kilogram meters per second. The mass of the fish is 310 kilograms. Velocity, if we rearrange the equation, is momentum divided by mass. So 4,500 kilogram meters per second divided by 310 kilograms. You go ahead and divide kilograms, or you divide and you get 14.5. Kilograms cancels kilograms, leaving meters per second, which we know is a unit for velocity. So our answer is the fish is moving at 14.5 meters per second, and that's pretty fast for a big fish. Alrighty, folks, I want you to go ahead and try, or let me know, how well do you understand Newton's third law? Are you super lost, or are you a momentum expert? Go ahead and answer that question. Alrighty, folks, so here's what we need to do. We have a Newton's third law practice, and I only want you doing problems 1 through 11. That's really all that we are going to cover when it comes to Newton's third law. The rest is about calculating conservation of momentum, which we are not going to do. We just need to know the definition of it. Make sure you're checking your answers on the key as you go to make sure you understand it. If you need help or you'd like to have me work through some practice problems, please feel free to check in and I'll be very happy to help you out. Tomorrow, we are going to do a lab that goes over and applies Newton's laws. It is a digital online lab. So that's going to kind of help with some clarification and kind of maybe making some of these concepts more concrete. So that's it, folks. And I hope that you have a fabulous day.